Hi students, this is Miss Haley and I'm going to be going through section 4.6, solving inequalities. So if you've got the handout, you'll see these steps that you're seeing right now. And these are the basic steps for solving our inequalities. The number 3, you notice, is in red. That step is only for our rational expressions, the ones that had the fractions, the x's and the fractions. So the best thing will be just to look at these steps as we go through and work some examples. Okay, so that's what we're going to do here. Alright, so here we go with the first example. Let's see. And I'm going to be writing with my finger on this thing, so it may not be quite as wonderful as the writing in the classroom. You might think my writing in the classroom is horrible, so this might be an improvement. I don't know. Alright, so example 1. If we want to solve, okay, let's start with one that's already factored. X minus 1 times x plus 4 equals 0. Only we want to do the inequalities, so let's make this greater than or equal to 0. Okay, so for this kind of problem, since it's already factored, we know if we were pretending like it was equal to 0, then we would just solve each one of these, right, and get x equal 1, x equal negative 4. Alright, so now what we're going to do, if you follow your the handout there, we're going to put these two numbers on the number line in the right order that they would be. So negative 4 would be to the left and 1 would be to the right. Since I had or equal to, these are going to get solid dots, closed circles. Okay. And now what we're going to do is pick any number from each of these sections, and we're going to use our calculators to plug them into the problem and see if it really is greater than or equal to 0. So back here, I think we will try negative 6. In between these two, let's try negative 1. And over here, how about 5? Okay, so now go to your graphing calculator. Up for the y1, type in x minus 1, x plus 4. Don't put anything about the 0. Alright, and now go to the table, and we want to put in those numbers, negative 6, negative 1, and 5. And what we want to know over here is if back up here in the original problem, is the answer greater than or equal to 0? So just a yes or a no for if it's greater than or equal to 0. So when we put in negative 6, we get a positive answer, which is greater than 0. When we put in a negative 1, we get a, oops, wait a minute. When we do the negative, I'm sorry, that was my mistake. That is, no, we actually got a, let's see, negative. No, that's right. I'm just confusing myself. Okay, positive, so yes. So we did get a yes here. Alright. When we put negative 1 in, we get a negative, which is not. So that's a no there. And when we put 5 in, we get another positive answer. So it is also greater than 0. And so now for the sections that said yes, you're going to go back up to the number line. Okay, we're going to shade the yes sections. So we're shading this section. And remember, this was a solid dot right there. And we're shading where the 5 came from. So over here. Okay, and then we would just have to write the interval notation for those. So I'm going to write those on the next page. -4 and 1. So, and it would get the bracket because it was the solid dot. It was the or equal to. And then same reason right here. And that would be our solution where both of those yeses were. Okay. All right, so let's try another one. Okay, if it started off with x squared minus x minus 5 greater than or equal to x minus 2. All right, well, the first thing we want to bring both of these over because we want a 0 sitting over here on the right side. So 0 right there. Over here, I would be subtracting the x and adding the 2. So it's going to say x squared minus 2x minus 3 greater than or equal to 0. Okay, solve it just like if that were an equal to, which means I could use quad 3 and get that x could be 3 or -1. Okay, so now we're going to put those on the number line. Okay, again, because we've got or equal to back up here, these will be solid dots, which means there'll be brackets when we go to our table here in a minute. All right, I'm going to turn the page. Okay, so we've got the -1 and the 3, the solid dots. Okay, and so now we're just going to, again, we're going to pick any number from each of these sections and plug it into the given problem to see if it's true or false. Or it doesn't even have to be the given. It can be that second one where we pulled everything over to 0. So let's try -3, 0, and 5. So use your graphing calculator. We're typing in, let's see, let's flip back. We'll use the x squared minus 2x minus 3. Okay, and we're going to be wanting to know if they are greater than or equal to 0 again. Greater than or equal to 0 when we go in our table. And so the x's we're trying are a -3, a 0, and a 5. So when we put -3 in, let's see, 9 plus 6 would be 15 minus 3, so that's going to be a positive, so that's a yes. When we put 0 in, we get a negative, so that's another no. And 5, we get a positive again. Okay, so these two sections are where my answers lie. So let's see. This section, this section. Okay. Not the middle, because it was a no. And so my interval notation, I'm going to squeeze it in up here. negative infinity to the negative 1, bracket, union with, bracket, 3 to the infinity. And remember, we're putting the numbers that were on those first marks, not the numbers that we tried in the table. Okay. Okay, now for the fractions, the ones that have the x's, as a fraction, our rational functions, we're still going to need everything over to one side. Whoops, not sure where that came from. Everything over to one side with the 0 on the right side. We're going to work that equal to 0, which means solving the top equal to 0. Okay. And place those numbers on the number line. With the circles according to the given inequality. Okay. And then, here's the big difference. You'll always, at that point, place any numbers that make the denominator equal to 0. Also on the number line, but always with an open circle. Y'all can tell I don't make a lot of the videos. Sorry about these little crazy things that keep happening. So no matter what the given problem, if it had the or equal or not, if it comes from making the denominator equal to 0, it always gets an open circle. The rest of the problem would be the same. We'd be testing a number from each section. If it works, you include that section. If it doesn't, you don't. Okay, so let me get a problem here on the next page and see what we can do. Okay, we're going to solve 2x over x minus 4 is less than or equal to 0. Okay, so first let's solve the top equal to 0. The top equal to 0. So that's going to be 2x, divide by 2 on each side, 0 over 2 still equals 0. All right, now the original problem said less than or equal to 0. So for this one will get a solid circle. Okay, but then I'm going to solve the bottom equal to 0. Let me see again. Let me look back. Okay, x minus 4 equal to 0. And so at x equal 4, since that came from what makes the denominator 0, which means we don't ever want to use it, that will get an open circle, even though we had or equal to in the given problem. Okay, so we're splitting up the number line this time. We've got 0